Hello, welcome back to the lecture series for AFM. Okay, this is lecture series 11, number 11. We continue with investment appraisal techniques. So now we come to three small techniques, but also can be tested sometime. MIRR, duration, and VAR. Okay. Each of these techniques is to deal with the problems of some of the basic techniques that you have learned in the previous lectures or in FM, the lower level. Okay, so we look at what is each of these and how it solves some of the basic techniques problem. We start with MIRR. MIRR, the modified internal rate of return. By the name, it is modified IRR. So it's to deal with the issues or the problem with IRR. Okay, what is the problem with IRR? Okay. See, when you use IRR for investment appraisal, we will compare the IRR with the company cost of capital. Okay, if the IRR is higher than the cost of capital, say IRR is 10%, cost of capital 7%, IRR is rate of return. So if return is 10%, the cost is 7%, it is good. Yeah. So the IRR greater than the cost of capital, we will accept the projects. And vice versa. Now, okay, but that is on the assumption there's only one cost of capital throughout the project's life. Okay, so if the project is 4 years, all the 4 years, the cost of capital is the same. Yeah, but that of course unlikely. Cost of capital can change over time. Yeah, after all, cost of capital depend on market value of shares and bonds, so it changes over time. Yeah, so okay, if the cost of capital changes over time, okay, let's look at an example like this. Okay, suppose we take 4 years. Okay, we take 4 years. Let's take the net cash flow. Okay. Say 10,000 outflow now. The discount factor, year 0 is always 1. So the present value, this is still 10,000. Okay. Let's say first year we have 3,000. Okay. Suppose the discount rate in the first year is 8%. So it's 1 divide 1.08. Yeah. 9.926. So 3,000 times 0.926. 2778. Okay. Let's say the second year, the cash flow is 5,000. The discount rate is 10%. So 1 divide 1.1 to the power of 2 because it's second year. So it's 0.826. Okay. 5,000 multiplied by 0.826. Okay. Let's say the third year, the cash flow is 7,000 and the discount rate is 12%. Yep. 0.712. Okay, 7,000 multiplied by 0.712. Right? Okay, say 4,000 in the last year. And the discount rate, let's say, is 5%. Yeah, say the discount rate is 5%. 1 divide 1.05 power 4. So that's 0.823. Okay. So this is a case where the cost of capital changes over the time. Yeah. The MPV. So MPV, there's no issue. Even the cost of capital change, we can still deal with it. Yeah, there's no issue with MPV. So it's positive MPV 5184. So the project is financially acceptable, right? Okay, there's no problem with MPV. If it comes to IRR, so to compute IRR, we take this cash flow, correct? Then what I've shown you, or what you have learned last time is you use two discount factor, okay? Then you work out the MPV, you work out the IRR, or you use the spreadsheet function, you can also find IRR, yeah? Okay, the spreadsheet function I will show you in the revision class and in the tutorial class, okay? You need to know spreadsheet functions for this paper to compute MPV and IRR. I will show in the tutorial class, I will show in the revision class, right? Okay. That is part of the professional skills that you need to know. So you take this cash flow, you work out the IRR, you will get one rate. Let's say the rate is example, just example, say 11%. Okay. You take the cash flow, you find IRR. Okay. You compare IRR with the cost of capital. If you compare 11 with 8%, you say accept. But if you compare 11 with 12%, then you say reject. See? So you will have a problems now. When the cost of capital changes over the time, you will have a problem when you compare with IRR. Then IRR becomes an issue, right? So how to overcome this problem? Okay. So when the cost of capital changes, you cannot really compare IRR with the cost of capital because you got problem. Yeah. Okay. So how do we overcome the problem? That is where the use of MIRR comes in. Okay. So what is MIRR? How does it deal with the problem? Okay. It's modified internal rate of return. Okay. We deal with the problems in two steps. Okay. We deal with the problem in two steps. The first step, yeah, we incorporate the cost of capital. We incorporate the cost, the company cost of capital into the project's cash flow. And compute what we call a terminal value. Okay, this is the value at the end of the project's life. The value at the end of project's life. We call terminal value. Okay, now like this. I have 4 years in this question, right? Okay, we work out the terminal value. The project is 4 years here, so at the end of year 4. Okay, at the end of year 4. Okay. Now, like this. At the end of year 4, you receive 4,000 cash flow. Okay. So at the end of year 4, your cash flow is 4,000. Right? At the end of year 3, you receive 7,000. Okay? You receive 7,000. Yeah? Okay, then we say this. after you receive this 7,000 at the end of year 3, you reinvest this money in year 4, and in year 4, you have returned 5%. Yeah, cost of capital is the required return. Okay, so you have returned 5%. So if you compound this forward by 5%, okay, you will get 7350. That's called terminal value. Yeah. Okay. Likewise, you receive 5,000 at the end of year 2. You will reinvest this money in year 3, return 12%, and then again in year 4, return 5%. Return 12%, return 5%. Yeah. So that will give you a terminal value of 5880. Okay. You receive 3,000 at the end of first year, you reinvest in the second year, you earn 10%, and then 12%, then 5%. Okay. That's what we do. Eh? Okay, so you compound forward to get the terminal value. 3881. Yeah? So you total all this is the terminal value. Okay. After you have got this terminal value, then you work out the IRR in the normal way. Okay, you work out the IRR in the normal way. Yeah. Okay, like this. So we take the projects now. Yeah. Okay. Year 0 is capital outflow 10,000. Capital outflow 10,000. Okay. Then year 1 to year 4, all this cash flow from year 1 to year 4, you have already compounded everything forward to this value in year 4. Yeah. So in year 4, you have a terminal value of, let me write down the word, okay? Let me write down the word. Capital 10,000, okay? Then you have terminal value 21,111. So all the cash flow from year 1 to year 4 is equal to this now. Yeah. Okay. So then with these two, you can now find the IRR. Okay. Either you compute it with what you learned last time, or for this paper, we're going to use spreadsheet function. Don't compute manually. Spreadsheet function is one of the professional skills they will test you. Yeah, I will talk about professional skills in detail during the tutorial class and also in the revision class. There are 4 professional skills that you need to know. I will talk about that in detail. There are 20 marks to earn this professional skill. Okay, we'll talk about it in detail in the tutorial class, in the revision class. So using the spreadsheet function, okay, you work out the IRR. Yeah, or we call it MIRR. Okay, so it is called modified IRR. Yeah, okay. Now, I just show you here since we are at this point. Yeah, okay. Just show you how to do it. Quite easy. Right. We just open up spreadsheet. Okay. Like this. Year. You have year 0 and year 4. Yes. Okay. The cash flow, year 0 is minus 10,000. Year 4 is 21,111. Yeah. Okay. So I want to find IRR equal IRR, open bracket. Okay. Now I want to discount these two cash flows. So year 0, double colon, year 4, close bracket. That's it. Okay. Just highlight the cash flow that you want to discount. Yeah. Enter. Okay. That is the IRR. Okay. 111%, because I just simply throw in some value just now. So I just simply throw in some value. Okay. We discount year 0 to year 4. Or no, I miss out 1, 2, 3. Okay, sorry, we got to do it again because we cannot skip the year. Okay, we got to do it again. This is not right. Okay, I skipped the year just now. Okay, going to take out this. Okay, year 0, year 1, year 2, year 3, year 4. Okay. There's no cash flow for year 1 to year 3. And oops, I got to delete this side, I think. Wait. Minus 10,000. No cash flow year 1, year 2, year 3. Year 4 is 21,111. Okay. Then I want to find IRR. Okay. Equals IRR, open bracket, discount from year 0 until year 4. Okay. 21%. Yeah. Okay. You can increase the decimal, you can reduce the decimal, up to you. Okay. Okay. You cannot skip the year, because if you skip the year, the discount factor changes. The discount factor follow is 0, 1, 2, 3, 4, like that. So if there's no cash flow, you must put in 0. Okay. Okay. That is the thing to take note when you do IRR. You cannot skip the year. Okay. So no value, just put 0. So it's 20.5%. All right. Okay. So modified IRR is 20.5%. Okay. Then you use it just like how you use IRR. So that is modified internal rate of return. Okay. Okay. That is one way to find MIRR. Third one. There's actually another approach to find MIRR. Okay. By using the MIRR formula. Okay, this is the one given. This formula is given in the formula sheets, and actually they want you to apply this formula. Okay, now is this. N is the year. PVR is the present value of return phase. PVR is the present value of return phase. PVI is the present value of investment phase. Okay. Okay. Now, what do you mean by investment phase? What do you mean by return phase? I'll explain now. Okay. It's like this. Suppose this is your project's net cash flow. Yeah. And you have outflow here, you have inflow here, outflow, inflow. When you start a project, it's always capital outflow. That is called investment phase. So this is present value investment phase. So come from here. Yeah. PVI come from here. Okay. Because you got to discount. Yeah. So from the first positive value onwards, we say we go into return phase. This is return phase. From the first positive onwards, we go into return phase. So PVR come from here. Yeah. In between negative, don't worry. Just put it as return as well. Okay, so like that. So that is by using formula. What is R? R is the WACC, the weighted average cost of capital. So, okay, we can use this formula to find MIRR, but there's a catch. This formula can only be used for single WACC. Only one WACC. Yeah. If you have changes in WACC, like this example, you cannot use the formula. So the formula has limitation also. Yeah. So if you have changes in WACC, you have to use terminal value approach. Okay. All right. Okay. But this formula is given to you. You can use that. Yeah. Okay. Okay. Now, another things to bear in mind, so I've just show you spreadsheet. If you look at Excel, in Excel, actually, there's also function to find MIRR, but you cannot use that function in your exam. In your exam, the Excel, the spreadsheet given to you don't have the MIRR function. That is not Excel, that is ACCA internal software. So it does not have the MIRR function, so you can't use that. Okay, that spreadsheet is quite limited function. Yeah. Okay. So you have to use this formula. Okay. Okay. Now let's illustrate this with one question. Okay, we're going to take this example here. The board of directors of Jonas Chemicals is considering the construction of a new distillation facility at Pembroke Refining Center, which is regarded as a key strategic component of the company manufacturing capacity. The investment proposal has passed to implementation stage. After much discussion, the board summarized cash flow as follows. So you have investment phase, see that? Outflow. From the first positive is recovery or return phase. Okay. Cost of capital 8%, expected NPV. NPV volatility is standard deviation. It's the fluctuation in the present value. Yeah. Standard deviation. It is this the fluctuation. Okay. We indicate by S. Yeah, we indicate by S. Okay. Compute the MIRR, recovery duration to be covered shortly, and then assess the value at risk. So in this video, I want to show you these three things. Okay, now let's start with modified IRR. Okay. Right, modified IRR. We take the projects, yeah. Until okay, 0. Okay. 1st January is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's 10 years here. Okay. So okay, got a lot of space, so no worry. The net cash flow, okay? Discount factor, present value. Okay. The net cash flow start from 9.5 million negative. Okay, put down all this cash flow. 9.5 million negative, 5.753, yep, and then 4.5, and then 6.4, 7.25, 6.5, 5.5, 4, okay, then -2 and -5. Okay, the discount rate is the cost of capital 8%. Okay, 8%. Yeah. Okay. When you find MIRR, the discount rate is WACC. This R is WACC. This R, the formula. Okay. This is WACC. Yeah. So you must use WACC. Okay. All right. So let's get the present value first. Okay. Okay. Then we get the present value. Okay. Yep. Now, right. Outflow is present value investment phase. This is 17.39. Yeah. From the first positive onwards, in between negative, we don't care. Yeah. This is present value return phase. Okay. So the present value of return phase, we add all together. 19.36. Yeah. The discount rate must be WACC, remember. Okay. So from here, we can now find the modified internal rate of return. This is the formula. Okay. Present value return phase divide present value investment phase. Okay. To the power of 1 over n. N is 10 years here. 10 years here. WACC 8%. Yeah, that is the answer. Okay. Now, 1 over 10 is actually root 10. The calculator will have this root function. Yeah. Okay. Okay, MIRR. Next one, project's duration. Now, in the first chapter, the last few videos, we have learned bond duration. Duration is the weighted average maturity period of bond. Okay. So this measurement, beside used for bond prediction of bond price, it can also be used in investment appraisal. See, duration is a measurement measured in year. It's weighted average year. Yeah. Okay. In investment appraisal techniques, one measurement that measure time is payback period. The project payback in 3 years, in 4 years. Yeah. So duration is also measurement in time. The duration can be used to replace payback period. Okay. So duration, weighted average maturity period of bond, right? We know that already. So we apply in investment appraisal. It is used to overcome the problems of payback period. These are also time measurement. Okay. What is the problem of payback? Two common problems with payback that you have learned last time. Payback is non-discounting. We don't discount the cash flow. Duration is discounting technique. Yeah. Duration, we use present value. Okay. Payback period, you only look at the cash flow up to the time you get back the capital. After you get back the capital, you don't care about the cash flow anymore, right? You're only concerned with getting back capital. It's not concerned with profitability. Okay. Payback ignore cash flow after the payback, but duration, no. Duration use all the cash flow in the return phase, everything. No cash flow are being omitted. Yeah. Okay. But return phase only. Because we are looking at payback. Payback is return. Yeah. Okay. All the cash flow in the return phase. Okay. So therefore, if we apply to this same question, okay, and let's work out the duration. Okay, we apply to the same cash flow here, and let's work out the project's recovery duration. Oh, no, the space not enough here. Okay, actually I can extend here, right? Okay, I go to extend from here. Okay, I take the year times by the present value. That's how we find duration. Weighted average maturity period weighted by the present value of cash flow. Yeah. Okay. So the year times by the present value. Okay. But the focus should be on return phase cash flow. It's about payback. Yeah. So return phase. So we start from year 3. So 3 times 3.57. 10.71. 4 years multiplied by 4.7. 18.8. Okay. 5 year times by 4.94 is 24.7. Okay. 6 years multiplied by 4.1 is 24.6. 7 year times by 3.21 is 22.47. Yep. 8 years times by 2.16. 17.28. Okay. 9 years times 1 is 9, but minus. Okay, here 10 year times 2.31 is 23.2. Okay. Okay, if we total all this, this is the weighted average. $86.36. Yep. Okay. Okay, and this side, the total is 19.36. Yeah. Okay. So duration is just a weighted average. Okay. The project's duration is 86.36 divided by 19.36. That's equals to 4.46 here. That's our duration. Yeah. Okay. You use this just like payback period. You take this and you compare with a target. The company will set the target. You compare with a target. Yeah. So if it's lower than the target, then you can accept. Okay. So the usage is just like payback period. Yeah. But it take all the cash flow in the return phase. See? Everything. No cash flow are excluded. It is a discounting techniques. We use present value. Right? Okay. Now that brings us to the last techniques which I want to cover here, the value at risk, VAR, projects value at risk. Okay, VAR. All right. Okay. Now, as I explain first, okay, VAR, projects value at risk. Okay, VAR is a form of risk measurement. Yeah, this is a form of risk measurement. It's actually a form of sensitivity analysis. Okay, it measures the maximum fall in the value of an investment, any investment. Okay, the maximum fall in the value of an investment over a specific time period at a specific level of probability. Okay, now two key points to be used when we assess value at risk of investment. It must be over a specific time period, a specific level of probability. Okay. Okay. This level of probability follows statistical tests. This actually statistical technique is it use normal distribution. Yeah. VAR is based on normal distribution. Okay. Okay. So we use confidence level. Okay, so there are three common confidence level used in any statistical test. 99% confidence level, 95% confidence level, and 90% confidence level. Okay, these are the common one, yeah? Which is equivalent to if they say 1% significance level, 5% significant level. It's the same thing, yeah? 5% significant level. Significant level refer to that P value. Yeah? The statistical test, the P value. And here is 10% significant level. Okay. Now, there's a formula. This is the formula. Please remember this because this formula is not given. If you need to use, you must remember. It's just basic statistical. Therefore, you are expected to know. Okay. Z score is the number of standard deviation. The number of standard deviations from the mean value, from the center value or the mean value. That's called z-score. Yeah. Okay. S is standard deviation. T is time. Okay. So S standard deviation, T is time. Okay. Now, how do we find this z-score? Yeah. Okay. Right. I show you now. This score is the number of standard deviation from the mean value. Okay. So how do we find this score? Now, we need to refer to a table called the normal distribution table. I show you one here. Okay. The normal distribution table. Okay. Just pick up one here. Okay, this is the normal distribution table. Okay. Just delete all the value first, then show you. Okay, okay. Oh, no, it's not really. Okay, I open up a fresh one. No handwritten. I open up a fresh one. A fresh one. Okay, a normal distribution table. You will get exactly the same like this in the exam. Yeah. Okay. So this normal distribution table. Okay, z-score is found from this table like this. Okay. This is normal distribution. Yeah. Total probability equals to 1. Okay. Now, in the middle is the mean value. Okay. First, say we want 95% confidence level. So this side is 5%. That is the significant level. Yeah. This side is called significant level. This side is called confidence level. Okay. Okay. This table gives us probability. All this value inside here, all these figure are probability. Yeah. Now, which the highest figure here is, you can see 0.5. Total probability is 1. The whole table area equals to 1. So 0.5 means half. Yeah. So they actually give you half the table. Okay. The figures in the table are all probability. They refers to the probability here. Probability here. Okay. Now, so half is 50%. Yeah. If here is 5%, here is 45%. That's 0.45. Correct? So the yellow area probability is 0.45, and that is the probability in the table. So now I go to the table, I look for 0.45. 0.45 is here. Can you see? It's in the middle of 0.4495, 0.4505. That's 0.45. Yeah. Okay. This is z-score. The value down here is z-score, the first decimal. This is the second decimal. So this is z-score, this is z-score. Yeah. Okay. So now you see this is 1.6, and then 0.004, 0.005. The center of this is 0.045. So the z-score at 95% confidence level is 1.645. First decimal, second decimal, 1.645. Right? So it's 1.645. Okay? That's 95% wrong place, not 99. That's 95%. 1.645. Okay? What about 99%? Okay. For 99%, yeah. Okay. If this is 99%, this is 1%. Okay? half is 50%. So if here is 1%, here is 49%, 0.49. But this area is 0.49. Yeah. Okay, so we look for probability 0.49 in this table. Okay, 0.49. Can you see here? 0.4901. That's 0.49. Yes. Okay. So can you see here 2.3 and up here 0.3. So it's 2.33, right? 2.3 and up here 0.3. Okay. So 2.33. One more, 90%. Right. If I change this now to 90%, so here is 10%, so here is 40%. Yes? Okay. So now I look for 0.4. 0.4 should be, can you see here? 3997, that's very close to 0.4. So it's 1.28. Okay, 1.28. So that's how you find the z-score. Yeah, 1.28. Okay. Alternatively, you can try to remember this if you can. Yeah, then you don't have to look at the table. Then you will be a bit faster in the exam. But they only ask you these three levels. Yeah. Okay. Okay. Now, so you know this score. Okay. So let's see how we apply this to measure risk in investment appraisal. This is risk measurement. Yeah. Okay. We go back to this question. Okay. Right. We want to assess the company likely value at risk. Go back to this question. Yeah. Okay. The project's value at risk. Okay. Let's do two level. Let's start with 95% confidence level or 5% significant level. Okay. Okay. 95%. 95% z-score is 1.645. Standard deviation is given. Yeah. S is standard deviation. Okay. Yeah. 1.02 million. Okay. 1.02 million. Square root of time, the project is 10 years. So that is value at risk. $5.31 million. Okay. Now, what does this mean? Okay. It means this. The MPV now, yeah, the MPV now is 1.964 million. Okay. We're looking at 95% confidence level. So here is 5%. That's value at risk, 5%. Okay. Value at risk, look at the fall in the value of investment. That's why we are looking at the left-hand side. Is when it is lower than the MPV now, a fall in value, lower than the value now, that's risk. Yeah. Increase in value is not risk. That's why we don't care about right-hand side. We only focus on left-hand side. Only the fall in value is risk. Okay. So the fall in value, okay. This is the maximum fall in value that we would expect. So we expect this to go down by 5.31 million. So 1.964 minus 5.31 is negative 3.346. Yeah, that's what we say. We are 95% confidence this project's MPV will not fall below this figure. Only 5% chance it will go below this figure. That's sensitivity analysis. Yeah. So we explain like this. Okay. We explain like this. We are 95% confidence. The project's MPV. Okay. Negative 3.346 million. Okay. Only 5% chance will be lower than that. Over 10 years project's life. When you explain value at risk, always two things, remember? Okay. Specific time frame, specific level of probability. Yeah. So the level of probability is 95% confidence level and 10 years time frame. Always must mention these two. Right. Let's do one more at 99%. At 99%. Z score 99% confidence level, Z score is 2.33. Times by the standard deviation, 1.02 million times by time square root of 10 years. That equals to 7.52. Yeah. Okay. Now, same idea. 99% confidence level. Here is 1% value at risk. Okay. The MPV now. Okay. Right. Value at risk is the maximum fall in value. Yeah. So the lowest point here, 1.964 minus 7.52. Okay. So we can conclude we are 99% confidence the project's MPV will not fall below negative 5.556 million over 10 years. Okay. So probability level, time frame, done. Okay. So in this video, we cover three different measurements. MIRR is to deal with the problems with IRR. When the cost of capital changes over project's life, you cannot compare IRR with cost of capital because it changes. Yeah. So we use MIRR. We incorporate the cost of capital into the cash flow first. We have terminal value. Okay. Now, then we have duration to overcome the problems of payback period. Payback is non-discounting, duration is discounting. Payback will ignore cash flow after the payback period. Duration take all the cash flow in the return phase. Yeah, it does not ignore cash flow. Then we have MIRR, risk measurement. Okay, the next video will be the last video on investment appraisal. We'll be looking at the last appraisal techniques, the real option, the Black-Scholes option pricing model. Bye-bye for this one.